morning to one and all. Myself, A. Mounika, working as an assistant professor in Marri Laxman Reddy Institute of Technology and Management. Today I will discuss about the topic computer system organization. This is there in operating system. First of all, what is operating system? So operating system is an interface between the user of the system and computer hardware. So means it can manage the resources that are available in the computer. So here, computer system organization, we are having three concepts. First one is computer system operation and storage structure and IO structures. First we will discuss about the computer system operation. So here first we are going to this diagram. So here we are having generally any computer, so we are having multiple CPUs, device controllers and memory. These all are connected through a common bus. So it is used to access the shared memory. So here each device controller, first look at the diagram. So here we are having CPU and different types of device controllers. So device controller is the in charge of the particular device. So here disk controller is the in charge of the disk. USB controller is the in charge of the input and output devices, means here mouse, keyboard and printer. Graphics adapter is the in charge of monitor. So here each device, we are call it as a device controllers. Here the device controller has a local buffer. Device controller has a local buffer. So here device controller is used to transfer the data between the peripheral devices and its local buffer. So when the data is stored in the local buffer, then the local buffer has a device driver. So here the device driver informs the CPU the data is ready to execute. Then the CPU transfers the data between the local buffer and memory. So once look at this. So one or more CPUs, device controllers and memory connected through a common bus, providing to share the memory. So these all are executed concurrently. So here each device controller is in charge of a particular device type. So CPU, first the CPU moves data from device drivers to main memory to local buffer to main memory. So once device controller informs the CPU that it has finished its work operation by causing an interrupt. So interrupt ante when the data is stored in the local buffer. So here the disk controller has a local buffer. When the data is stored in the local buffer, immediately the device controller sends an interrupt to the CPU. The data is ready to execute. Then you can send it to the main memory. So here the CPU, what is the work of CPU? Here the CPU moves the data from device controller, the data is there in local buffer, that is transferred to the main memory. So here the CPU means it will get the interrupt from the device controller. Then immediately the CPU stops the current process execution. Interrupt service routine program was executed. So after completing the execution of the interrupt service routine, then previous program which is executed by the CPU, that was executed. So then before that we are bootstrap program. So before executing the interrupt service program, the bootstrap program is loaded or rebooted, means the operating bootstrap program is used to load the operating system kernel and starts its execution. This is the initial step. So the bootstrap loader is stored in the ROM only, means read-only memory. So next structure is storage structure. Storage structure mainly divided into three types. So main memory or primary memory, secondary memory and cache memory. So main memory or primary memory. So main memory is used to communicate with the CPU. We know already the CPU can execute the program when the program resides in main memory only. The CPU can execute the program if the program resides in main memory only. So example, RAM means random access memory. Main memory is a volatile memory. When the power is turned off, the contents of memory will be lost. So next one is secondary memory. Secondary memory is used to store the data temporarily in the computer. For backup purpose, we are using the secondary memory. Secondary memory is a non-volatile memory. When the power is turned up, the contents of secondary memory won't be lost. But the CPU can't access the data which is present in secondary memory. The best example are hard disk, magnetic disks, and magnetic tapes. Next is cache memory. Cache memory is very faster and smallest memory. Smallest memory, and the small in size. So cache memory is used. The cache memory is used to store the frequently stored instructions. So it is having three types of characteristics. So the size or capacity, cost per bit, and access speed. So here we are storage capacity. Storage capacity of the cache memory will be very in MBs, like 1 MB, 2 MB, 8 MB. The final is 8 MB, whereas main memory storage capacity will be in GBs, means 4 GB and 8 GB, and hard disk capacity will be in TBs, like 1 terabyte. So cost. So cache memory is very expensive. Main memory is also expensive, but relatively cheaper than the cache memory, whereas hard disk is very cheaper than RAM. Access speed. Cache memory is very faster, but the problem is very expensive. Main memory is also faster, but relatively slower than cache memory, whereas hard disk is very slower. So compared to the memory, so main memory size is cache memory size is very small, then memory size is little bit larger than the cache memory, and secondary memory size is larger than the main memory and cache memory. So as the storage capacity, means the storage capacity of memory increases, the cost per bit is decreases, and access speed will also become slower or longer. So in computer system organization, next concept is IO structure. So IO structure, we know all, any general purpose computer consists of one or more CPUs and control devices, memory connected through a common bus, providing to access the memory. Each device controller has in charge of a particular device. Each device controller has a local buffer. The device controller is responsible for moving the data between peripheral devices and its local buffer. Each device controller has a device driver. Once the transfer of data is completed, device controller informs to the device driver, and in turn it informs to the CPU. This form of interrupt driven IO is fine for moving all small amount of data, but can produce high overhead when used for bulk data movement such as data IO. To solve this problem, we are using the direct memory access is used. Means here, so when we want to change the large amount of data, this is not suitable for moving the data, large amount of data from device to memory. We are using DMA, means direct memory access. So here the CPU doesn't interfere in this topic. Means direct memory access structure used for high-speed devices able to transmit information is close to memory speeds. DMA transfer blocks of data from buffer storage directly to main memory without CPU intervention. Only one interrupt is generated per block rather than one interrupt per byte. So see this diagram. When so here only small amount of data is executed by using CPU only. If you want to execute the large amount of data, then we are using the DMA, direct memory access. Here there is no intervention between the device and memory. The CPU is not intervene. Okay, thank you.